In December 2023, NASA's Juno spacecraft swooped within 1,500 kilometers of a moon that looks like it belongs in a nightmare. Volcanoes erupting across an alien landscape painted in yellow sulfur and red lava rings, mountains twice the height of Everest jutting from plains of frozen gas, and a surface so violently active that not a single impact crater exists anywhere on it. This was the closest any spacecraft had come to Jupiter's moon Io in over 20 years. And what Juno found there would overturn scientific theories held since the 1970s. But here's what makes this story truly wild. Just a year later, in December 2024, Juno detected something that broke its own instruments. The most powerful volcanic eruption ever recorded on any body in our solar system. An event releasing 6 times more energy than every power plant on Earth combined. This is what NASA actually found on Io. To understand why scientists are losing their minds over these discoveries, you need to know what we thought we knew about this moon. For 44 years, the leading theory was that Io had a global magma ocean, a continuous layer of molten rock sloshing beneath the surface, feeding all 400 volcanoes like one giant interconnected reservoir. The idea made sense. Jupiter's gravity is so intense that it squeezes Io's solid rock, creating tides not in water, but in stone. The ground itself rises and falls by 100 meters every orbit. That's like a 30-story building appearing and disappearing in the bedrock every 42 hours. With that much flexing generating heat, surely the interior had to be completely molten. Then Juno flew closer than any spacecraft since 2001. On December 30th, 2023, Juno passed within 1,500 kilometers of Io's surface and collected precision gravity measurements. Then it did it again on February 3rd, 2024. Scientists combined the data, ran the numbers, and published their findings in the journal Nature on December 12, 2024. The global magma ocean doesn't exist. Lead researcher Ryan Park described what they actually found. Io's mantle is kind of like a slushy, mostly solid rock with melt in the cracks between. Each of those 400 volcanoes draws from its own individual magma chamber, not some vast underground sea. The most volcanically active world in the solar system doesn't work the way we assumed for 4 decades. That finding alone would have made 2024 remarkable. Juno wasn't done. 15 days after the Nature paper dropped, on December 27, 2024, Juno's infrared instrument detected something in Io's southern hemisphere that scientists are still processing. A volcanic hotspot covering approximately 100,000 square kilometers. That's roughly the size of Iceland. 5 times larger than Loki Patera, which was already the biggest lava lake in the solar system. The energy output? Well above 80 trillion watts. To put that in perspective, every power plant on Earth combined produces about 13 trillion watts. This single eruption on Io was releasing 6 times that amount. The infrared signal was so intense that it saturated Juno's detector, maxed it out completely, and this was from 74,400 kilometers away, 50 times farther than the close flybys. Alessandro Mura, lead scientist on the infrared instrument, described what they think happened. Multiple volcanoes erupted simultaneously, their brightness increasing more than 1,000-fold. A single enormous eruptive event propagating through the subsurface for hundreds of kilometers. Mission lead Scott Bolton called it the most powerful volcanic event ever recorded on the most volcanic world in our solar system. Now, to appreciate just how ridiculous Io is, let's talk about Loki Patera. Because until December 2024, this was the record holder for the most impressive feature on this moon. Loki Patera is a volcanic depression 202 kilometers across. That's longer than the distance from New York City to Philadelphia. The entire thing is a lava lake, the largest active one we know of anywhere. It alone produces about 10% of Io's total heat output. But here's the detail that blew scientists away when Juno imaged it up close. The surface of this lava lake is as smooth as glass. Scott Bolton announced it at a scientific conference in Vienna, comparing it to volcanically created obsidian on Earth. Smooth, dark, glassy crust with islands embedded in it, each rimmed by glowing orange lava where the hot magma meets cooling rock. Those islands, by the way, have been sitting in the same locations for at least 45 years. Voyager 1 first photographed them in 1979. They're anchored to the lake floor like rock formations in a sea of fire. The lake works through periodic overturning. A thin crust forms on the surface, cools, thickens, becomes denser than the magma beneath, and eventually sinks. Fresh molten rock surges up to replace it. Juno tracked a resurfacing wave crossing the lake at about 1 kilometer per day. The whole cycle takes 400 to 600 days. Imagine standing on the shore of a lake 200 kilometers wide, watching a wave of fresh lava slowly sweep across a surface of black volcanic glass, revealing glowing orange magma underneath. That's Loki Patera. Scientists also identified something they're calling Steeple Mountain, a peak standing 5 to 7 kilometers tall with an extremely steep spire-like profile. They compared it to the Matterhorn, except no one knows how it formed. It shouldn't exist according to standard volcanic processes. And this is where Io gets even stranger, because despite being dominated by volcanism, the tallest features on this moon aren't volcanic at all. The champion is South Busal Mons. It towers 17.5 kilometers from its base, with some measurements putting it at 18.2 kilometers. That's roughly twice the height of Mount Everest. Its southeastern face is a near vertical cliff 15 kilometers high, taller than the cruising altitude of commercial aircraft. These mountains form through a process we don't see anywhere else in the solar system. Volcanic deposits pile up on the surface at rates up to 1 centimeter per year. As older layers get buried deeper, they compact into dense bedrock. Enormous compressive stresses build until large blocks, roughly 100 kilometers across, get thrust upward along deep faults. The result is these isolated massifs erupting from sulfur plains like geological exclamation points, with no relationship to the volcanic vents surrounding them. Mountains that exist because the moon can't contain its own violence. So what's actually causing all this? Why is Io the most volcanically active body we've ever found? The answer involves 3 moons and a gravitational dance that's been going on for billions of years. Io, Europa, and Ganymede are locked in what's called the Laplace resonance. For every single orbit Ganymede completes around Jupiter, Europa orbits exactly twice, and Io orbits exactly 4 times. A 4 to 2 to 1 ratio maintained with precision over cosmic timescales. This orbital relationship means the 3 moons periodically tug on each other gravitationally. Those tugs prevent Io's orbit from becoming perfectly circular. It maintains a slight elliptical shape instead, and that eccentricity is everything. As Io swings between its closest and farthest points from Jupiter every 42.5 hours, the planet's gravity stretches and compresses the moon's interior. The tidal bulge rises and falls by up to 100 meters. Solid rock, flowing like an ocean tide, except the tide is made of stone. For comparison, Earth's solid body tide is measured in centimeters. The tidal forces on Io are 20,000 times stronger than the moon's pull on Earth. All that flexing generates frictional heat on a planetary scale. Io's total heat output reaches 60 to 160 terawatts. The tidal heating alone produces about 200 times more energy than radioactive decay would in a body of Io's size. Here's the wild part. Without the Laplace resonance keeping its orbit elliptical, Io would be a dead, cratered world resembling our own moon. Similar size, similar mass, completely different fate. Jupiter is literally squeezing Io's insides out. As Bolton put it at a December 2024 conference, Io is orbiting a monster. Let's talk about the surface itself, because Io looks like nothing else in the solar system. Scientists have called it a pizza since 1979, and honestly, they haven't been able to shake the comparison. Yellow sulfur covers about 40% of the surface, dominating the equatorial regions. Red and orange patches, about 30%, come from short-chain sulfur deposited around active volcanic vents. These mark recent eruptions. White and gray areas are sulfur dioxide frost, the most abundant ice on Io. And those black spots, only about 1.4% of the surface, are fresh silicate lava flows and pyroclastic deposits. This is the most colorful solid body in the solar system, painted by volcanism in real time. Here's something that took scientists decades to prove. Most eruptions on Io produce basaltic silicate lava at temperatures between 1,100 and 1,250 degrees Celsius, but peak temperatures reach approximately 1,527 degrees. That's roughly 1/3 the temperature of the sun's surface and hotter than any lava flowing on modern Earth. Those extreme temperatures indicate something called ultramafic magma, similar to a type of lava called komatiites. Komatiites haven't erupted on Earth for over 2 billion years. Studying Io is literally watching our planet's violent Archean youth in real time. The volcanic plumes on Io come in two dramatic flavors, and they're both incredible. Prometheus-type plumes are long-lived umbrella-shaped clouds reaching 50 to 150 kilometers altitude. They form when lava vaporizes surface sulfur dioxide frost. Prometheus itself has been continuously active for more than 45 years. Every spacecraft that has ever looked has found it erupting. Voyager saw it in 1979, Galileo saw it in the 1990s, Juno sees it today. Then there are Pele-type plumes. These are far more explosive, blasting sulfur-rich gas and silicate debris 300 to 500 kilometers above the surface at ejection speeds of 1 kilometer per second. The plume from the volcano Pele deposits a red ring over 1,000 kilometers in diameter, visible from orbit as a giant bullseye. During New Horizons' 2007 Jupiter flyby, the spacecraft captured the Tivashtar volcano erupting a 330-kilometer-tall plume with exquisite filamentary structure. It remains one of the most visually stunning images in planetary science. Now here's something that sounds made up, but isn't. Io has an atmosphere that vanishes every time Jupiter gets in the way of the sun. The atmosphere is about 90% sulfur dioxide at a pressure billions of times thinner than Earth's. When Io passes into Jupiter's shadow, a roughly 2-hour eclipse occurring every orbit, the temperature drops from about minus 130 degrees Celsius to minus 168 degrees Celsius. That's below sulfur dioxide's freezing point. The atmosphere literally collapses within minutes as gas freezes onto the surface, an 80% pressure drop. Then Io emerges back into sunlight, and the atmosphere reforms in approximately 10 minutes. Faster than models predicted. It essentially reinflates from nothing, over and over, every 42 hours. Io also displays equatorial auroras. Every other body with auroras has them at the poles, driven by solar wind interacting with magnetic fields. Io's auroras glow at the equator instead, driven by Jupiter's magnetosphere rather than the sun. Green from sodium, blue from sulfur dioxide, red from oxygen. There's more. Io acts as a giant electrical generator. The moon develops 400,000 volts across itself and drives 3 million amperes through what's called the Io flux tube, a magnetic connection to Jupiter. It loses approximately 1 ton of material per second to Jupiter's magnetosphere, primarily sulfur and oxygen ions stripped from its atmosphere. This creates the Io plasma torus, a glowing donut of ionized gas encircling Jupiter. The material inflates Jupiter's magnetosphere to over twice its expected size and creates brilliant auroral footprints on Jupiter's poles. The radiation environment near Io is lethal, about 3,600 rem per day at the surface. That's roughly 5 times a fatal human dose every single day. Any future robotic explorer would need serious shielding just to survive. The modern discovery of Io's volcanism is one of science's greatest stories, and it starts with one of the most spectacular predictions ever made. On March 2, 1979, just 3 days before Voyager 1's closest approach to Jupiter, planetary scientists Stanton Peele, Patrick Casson, and R.T. Reynolds published a paper in the journal Science. They had calculated the tidal heating that Jupiter's gravity should produce. Their final sentence: consequences of a largely molten interior may be evident in pictures of Io's surface returned by Voyager 1. 3 days. They predicted active volcanism 3 days before the spacecraft arrived to confirm it. On March 8, 1979, JPL navigation engineer Linda Morabito was processing a long-exposure image of Io when she noticed a gigantic crescent-shaped anomaly off the moon's limb. Sleep-deprived from weeks of flyby operations, she later wrote, "I could feel tears begin to roll down my face at the sight of a world more unexpected than imagination itself." She had discovered a volcanic plume 270 to 300 kilometers tall, the first active volcano ever found beyond Earth. Over 6 hours, she and colleagues systematically eliminated every alternative explanation. Camera artifact, background moon, lens blemish, none of them fit. The anomaly correlated with a surface feature later named Pele. When Voyager project scientist Ed Stone saw the image, he stared quietly and repeated, This has been an incredible mission. Voyager 1 ultimately identified 8 active volcanic plumes. The solar system would never look the same. The Galileo orbiter, which arrived at Jupiter in 1995 and operated until 2003, performed 6 close EO flybys. It approached as close as 180 kilometers in October 2001. Despite crippling hardware failures, a stuck antenna, and a jammed tape recorder, Galileo proved that Io's volcanism is silicate-based, not merely sulfur-driven. The lava temperatures exceeded 1,500 degrees Celsius, hot enough to be rocky magma. Galileo also confirmed Io has a large iron core and is fully differentiated like a terrestrial planet. When the mission ended, controllers deliberately plunged the spacecraft into Jupiter, not to save fuel, to avoid accidentally contaminating Europa's potential ocean with Earth microbes. That's how revolutionary the Galilean moon discoveries were. They changed our definition of where life might exist. Among the 4 Galilean moons, Io represents one extreme of a remarkable gradient. Callisto, the outermost, is geologically dead. It has the most heavily cratered surface in the solar system, unchanged for 4 billion years. It doesn't participate in the Laplace resonance. Ganymede, the solar system's largest moon, bigger than Mercury, has an intrinsic magnetic field and a subsurface ocean. But it's mostly geologically quiet today. Europa has active ice tectonics, a global liquid water ocean under a 15 to 25 kilometer ice shell, and is a prime candidate for extraterrestrial life. And then there's Io, closest to Jupiter, volcanic hellscape generating 100 times Earth's volcanic energy output. The driest known object in the solar system, with the lowest water content by atomic ratio of any known astronomical body. So here's the frustrating part. Despite being one of the most scientifically compelling targets anywhere, no dedicated Io mission has been approved by any space agency. NASA's Europa Clipper launched in October 2024 and arrives around 2030. It focuses exclusively on Europa. The European Space Agency's JUICE mission launched in April 2023 and arrives around 2031. It targets the icy moons, especially Ganymede. Neither will perform Io flybys, though both may observe volcanic activity from a distance. The most promising proposed mission was IVO, the Io Volcano Observer, a Discovery-class concept that would have performed 10 close flybys within 200 to 500 kilometers. Led by Alfred McEwen at the University of Arizona, IVO was selected as a finalist in February 2020. Then in June 2021, NASA chose 2 Venus missions instead. As of now, Io remains without a dedicated mission on any agency's roadmap. Think about that for a second. This is a moon where the ground rises 100 meters from gravitational forces, where volcanism has been continuous for 4.57 billion years since the solar system formed, where scientists just recorded an eruption powerful enough to saturate instruments from 74,000 kilometers away, a moon that in 2024 alone revealed it doesn't have a magma ocean, grew a brand new volcano that didn't exist 27 years ago, and produced the most powerful volcanic event ever recorded anywhere. And no one is going. In April 2024, Catherine DeClear's team used the ALMA telescope to measure sulfur isotopes in Io's atmosphere. They proved that Io has lost 94 to 99% of its original sulfur to space over its lifetime. Lighter isotopes escaped over the eons, leaving behind heavier ones. Io has been bleeding into the void since the solar system was young, and it's still bleeding today. In September 2024, scientists announced the discovery of a brand new volcano just south of the equator. Comparing February 2024 images with Galileo images from November 1997 showed that this entire volcanic complex, 285 square kilometers of lava flows, 100-kilometer-long dark streams, red sulfur deposits, none of it existed 27 years earlier. A whole volcanic system materialized from nothing in less than 3 decades, on a moon where we've only had spacecraft visit a handful of times. What else has appeared since the last time we looked? What else is happening right now that we'll never see? The research from 2024 paints Io as something more than a volcanic curiosity. Scientists are calling it a Rosetta Stone for understanding planetary interiors. Juno's discovery that tidal heating doesn't require a global magma ocean has direct implications for how we model Europa's ocean, how we think about Enceladus's geysers, and how we predict conditions on rocky exoplanets orbiting close to their stars. The detection of ultramafic lavas at temperatures not seen on Earth for billions of years means Io offers a living laboratory for studying our own planet's violent youth. The December 2024 eruption, powerful enough to saturate instruments from 74,000 kilometers away, suggests subsurface magma networks far more extensive than anyone imagined. A plumbing system connecting volcanic centers across hundreds of kilometers. From Galileo Galilei pointing a telescope at Jupiter in January 1610 to Linda Morabito crying over a volcanic plume in March 1979. From Voyager 1, identifying 8 active volcanoes to Juno hovering 1,500 kilometers above a glass-smooth lava ocean in December 2023. And still, after all of that, Io has no dedicated mission on the books. The most volcanically active world in the solar system remains, in many ways, one of the least explored. Every time we look closer, it rewrites what we thought we knew. Maybe that's the point. Io isn't just a moon. It's a reminder that the universe is stranger than we assume, more violent than we expect, and far from finished surprising us. If you found this fascinating, you're going to want to see what NASA discovered inside Europa's ice shell. That video is on screen now. And if you want more deep dives into what we're actually finding out there, subscribe. I cover the discoveries that don't get enough attention. I'll see you in the next one.